Hello, so this is going to be the third video of the year, second section of that first chapter. So this section is kind of a little bit more just like housekeeping things. If you've already kind of noticed, chapter 1 is not necessarily going to be the hardest chapter we ever do. We typically really won't even get into more pre-calc topics until a little bit later in the year. Maybe even around like headed toward that semester break is when we'll start to really see more pre-calc topics. Right now, we kind of redo some Algebra 1, Algebra 2, get you thinking about those topics again. We redo them a lot at just a little bit harder level, so it's not like you're retaking Algebra 2 again. We do them all at a harder level and we go much quicker through them, but you have seen a lot of this stuff before. So I like to call this section like a housekeeping section basically, because for the most part, this section out of chapter 1 is just kind of like a big mishmash of different things that we need to talk about at some point in time, but none of them really go all that well together. It's just kind of like, hey, here's all these things that we need to make sure students know, and let's throw them all in one section together. So it's kind of all over the map, all things to do with functions. So that's the title of 1.2. It's all functions, just different parts of remembering what functions have to be, what isn't a function, what is a function, domains of functions, kind of all that fun stuff. So the first thing I kind of did here was just define a function for you. Now I'm going to bring it a little closer because I really don't think that you can read that very well. Something's kind of up with my, oh, that's why. Okay. It's not on we have little webcams, and for some reason my computer hooked up to the normal crappy camera, not my webcam. So we'll deal with it for this one. So what a function is, and this is my kind of more simplified version of like the book definition that you'd go and find. A function is basically just when every x value is mapped to exactly one y value. So this exactly one is super important. When it's more than one, less than one, more than one, it's not a function. Okay? So when that doesn't happen, we cannot call it a function. There's a lot of things we can't do with it. So I gave us the following 3 examples to try to say, is it a function or are they not functions? So there's 3 examples here. We're going to go through all 3 of them. So when we talk about a function, when we're looking specifically at points, again, I should only have one x value that's mapped to one y value. So if anything ever doubles up and those points are not the same, then I don't have a function. So when we're looking at this input-output, like XY table, we could replace this definition by saying every input must have exactly one output. So when you go through this list, what we want to do is check, are there any x values that are the same? Okay, so I go through, I have 2, 3, 4, 2, 5. So what I'm saying is I'm having 2 x values, okay? If these 2 inputs have the same output, meaning they were both, like the 2 points were 2, 5, 2, 5, that's the same point, so it's okay. If they have different corresponding y values, then I'm not a function. So let's go through. This one is 2, 10. This one is 2, 11. So I have 2 different points on my same x coordinate. What this would look like is over at 2, way up at 10, up here I'd have a point, and then at 11 I'd have a point. So whatever else happens in this function, at some point, I'm going straight up and down, okay? That means we cannot have that. We cannot have 2 different outputs to the same input. So this one is no. It is not a function. Let's move on to number 2. I'm going to make this line a little bit darker. So what we have here is a quadratic function. So it's giving us a parabola. When we're looking at graphs, what we like to say is, do they pass the vertical line test? If you remember, that vertical line test was basically, if you drew a dashed vertical line at any point in this graph, would it hit the graph more than once? If that answer is true, then it's not a function. if at any point in this graph, I can draw a dashed line, vertical line through my graph, and it never hits the graph more than once or the function more than once, then it is a function. So when we're going through any, oh, that marker's dead. I can perform the vertical line test everywhere through here, and I'm only ever hitting once. If I ever went through twice, it wouldn't be a function. Since I'm drawing all these vertical lines and it's passing, that's saying yes, it is a function. Now let's go on to number 3. If I perform the vertical line test on number 3 over here, right away, my very first one, I'm saying, uh-oh, I went through once and I went through twice. So it does not pass a vertical line test. So no, it is not a function. Okay, these are determining how we determine functions graphically. So what we also need to know is how do we determine whether or not something's a function algebraically, because we're not always lucky enough to get a graph. So when we look algebraically, I'm going to show you exactly 2 different scenarios. The first scenario is negative x plus y squared equals 1. The second, x squared plus y equals 1. Okay. Now, I'm doing kind of the exact opposite, right? They look super identical here with the fact that the squared is on the y here and the squared is on the x here. So when we determine if something is a function, I like to always isolate my y. So let's isolate our y's in both of these functions. Doing so, here I need to add x. So it would be y squared equals x plus 1. Okay, let's do that same first step over here. I need to subtract x squared now. So I get y equals negative x squared plus 1. So on this side, I'm isolated. Okay, so we're going to come back to this one in a second. On this side, my y is still not isolated yet. I still need another step. So in order to get rid of a square, we have to do the opposite. So we're going to take the square root. On this side, I get down to y. Over here, anytime we take the square root, we like to take that plus or minus symbol, right? That's something I'm going to preach a lot this year is when we have that square root, we have to add in the plus or minus because we don't know is what's coming out of there positive or is it negative. Whenever something was squared at one point, it could have been positive or negative. We just never know. So I'm isolated on both sides now. So now what I want us to do is, let's think. If I put something in for x, what would I get out for y? Sometimes it just has to be a trial and error. When I'm looking at, and you'll be able to identify a little bit easier after we're done with these examples, sometimes you just have to do trial and error though. Like, well, let's try putting in 2 for x or 3 for x or something. And then seeing, do I get one y output or do I get 2 different y outputs? So let's try this one over here first. I'm going to claim that x equals 3. And I want to know, well, if I'm going to say x equals 3, just trial and error, what would I get out for my y value then? Do I get 1? Do I get 2? Do I get 4? How many y values do I get out? Because that determines whether or not it's a function. So let's put in, let's put in 3 for x. Okay, so now I'm getting 3y equals plus or minus the square root of 3 plus 1. What is 3 plus 1? That is, can you see over here? I'm going to bring this up over here so you can kind of see better. So I'm right now at y plus or minus square root. 3 plus 1 is 4, right? So square root of 4 is 2. Now I'm getting y equals plus or minus 2. What do we know about plus or minuses? Basically, that's saying that we have to take the positive version of 2 and the negative version. So I would have an xy table saying that when x equals 3, y equals negative 2. And when x equals 3, y equals positive 2. I have two different outputs to my one input. Because of that, this is not a function. Some people ask me, so if I see that the y is squared, can I just know that it's not a function then? Absolutely. That's 100% what you can do. That's the whole point of this. But I will always expect you to be able to explain that. Especially this would probably be a really good honors question at some point in time to throw in. But that's the explanation behind it is more what I'm looking for. I like that eventually you'll be able to identify, I see that y is squared, it's not going to be a function then. But I still need to know that you know why that's the case. So when we look over at our second example, if I input any number, and I would let you go ahead and try this, I don't want to keep taking up a ton of time, but if you were to try any random number in for x, I would challenge you to try to find something that has more than one output to it, okay? So because of that fact, this, yes, will be a function. And I'm hoping you're already kind of seeing, like, I've seen this kind of a function before. It's just a quadratic. You could have a negative slope, right? Or that negative x value in that function. It's just a normal quadratic function. Yes, that is a function. If you want to even go ahead and graph this out on your calculator, you'd kind of be able to see that happening. Okay. So, a couple other things I want to talk about is if we're ever saying, and I get this a lot, what does g of x mean? Okay, because we're going to be doing a lot of substitution like this. So basically what I'm saying is that if I were to say, okay, go ahead and take g of -6, and you are given the function, let's not do that one actually, let's do a different one. If I give you the function g of x equals -x² plus 4x plus 1, and I said I want you to find g of 2. Basically what I want to know is, do you know how to do this? Are you able to perform that substitution? I've found that it's not like unheard of to not be able to not know this at this point in your math career. I don't even need us to solve this out all the way. I just want to know, can you put in what you need to? So basically, when I'm telling you to do substitution like this, or take g of something, or f of something, anything like that. This could be a g, it could be a f, it could be an m for all I know. It could be any letter out here. But when you have something besides x in your parentheses, right? It was an x up top, now I'm saying it's a 2. That's telling you to substitute in the 2 for every x you see, okay? It was x, now it's a 2. That means in this function, every time I see an x, I'm going to put a 2. Important thing to know is that you have to leave everything else that was there, right? So if there was a negative out in front, I need to leave that there. Okay, I'm only replacing the x with 2, meaning that the squared needs to remain there. I am only replacing the x with 2, meaning the 4 needs to stay there. This 1 still needs to come out from behind, okay? Then you would have to solve this through all the way. Again, I don't want to take up too much time doing all of those little details, but you could solve this through all the way and get that actual g of 2 answer, okay? So being able to know that that's that substitution method and that everything remains the same. It's way too often that I see some students like forgetting to leave the squared there or forgetting to add in the 1 in the end. Those are real things that happen all of the time. Okay, so if you have your books, I want you to flip, and I will bring mine up for you, but I want you to flip to the very last page, right before the back cover. And I specifically want you, this is what it should look like. And again, this webcam is really awful, so you're barely going to be able to see this. But this is the library of parent functions. So specifically, I want you to look at all of the domains. So the domain of my square root, the domain of my absolute value, of just the linear functions. So domain is the very, very top one there. Basically, you should be seeing like, wow, all of these domains are negative infinity to positive infinity for the most part. That's an 8. I'm sorry. It's been a long time since I wrote an infinity. I guess I forgot how to do it. Okay, one thing to make sure of is that we cannot use brackets when we're saying infinity, right? Brackets say that it's including. We don't know what infinity is. Infinity just keeps going, right? So you can never include infinity. Infinity is always just included, right? So always use parentheses when we're talking about domains with infinity in them. Let me even just recap. What is domain? So if I'm looking at the following function, we'll say that that's 1. Okay. So I don't need to know anything about this function to be able to say what its domain is. Domain deals with how far left and right I'm going. Okay, so we go with the left first. So left is on the left side of that domain, and the domain brackets. And then on my right side, I'm saying how far right am I going? So some students ask like, oh, I always get domain and range mixed up. Same, it happens. One way, and this is probably a really stupid way, but it works for me, and it's always worked for me. Like when I was in high school, I figured this out, and it worked for me my entire career now. So domain is dealing with your x values, right? I'm going along my x-axis, how far left and how far right. This axis right here is my x-axis. So when I was super little, like I mean probably 5th grade little, and they taught us that this was the x-axis and this was the y-axis, what I did was I was like, oh, the only way this is going to make sense to me is if I kind of make this into a y. Right, so you can kind of see like the y-axis is the tail of the y. It's super stupid. But then I decided like, oh, well, since range is my y-coordinates, how far down and how far up I go, right? How far down on the y-axis do I go and how far up do I go? In my head, I made that like, oh, this little tail on the G, that's like my y, because a G kind of looks like a y. Super stupid. If it helps you, it helps you. If it doesn't, I'm so sorry. You're going to have to find some other way. But that's how I remember domain and range. Now, we're not talking about range right now. We don't care about that. What I really care about right now is domain. So you can see right here, why is domain generally negative infinity to positive infinity? These arrows, this is going to keep gradually going out further, little by little by little. It's never going to stop. But this arrow says I'm going to keep going out. Same with this one. I'm going to keep going up and out. So generally, you're always going to have that it's going to eventually keep going out. Without the presence of asymptotes, nothing's ever going to stop it. Now, range is different because I'm never going to go past this positive 1, right? I'm never going to come down into this territory. Same with other functions like an absolute value. I might start at my origin and go out. I'm never going to go down further, but I'm always going to go out into the left and right further. Okay, so generally, but we can also talk about linear, always going left and right further. So looking at all of these functions, they're always going to keep going left and right. Unless, of course, something like a discontinuity or an asymptote or something like that stops it. So I want to teach you, how do we find those discontinuities? How do we find those asymptotes? When would I ever be able to say that my range, or that my domain isn't negative infinity to positive infinity? So I want us to identify the domain of f of x equals 1 over x squared minus 4. Okay, so specifically when we're looking at something like fractions, what do I have to watch out for? A discontinuity or an asymptote would be when my denominator equals 0. So let's think, what's a number that would make my denominator equal 0? Well, it would have to be, since I have a -4, I would have to somehow make x squared equal a +4. What's the only number that's going to get me to x squared? Or to 4 using x squared? If I took 2 squared minus 4, this is 4 minus 4, that would be 0. Okay, but is that all? What happens to a negative number when you square it? It turns positive. So let's also say, well, if I use -2 squared minus 4, this is still +4 minus 4, and that is still 0. So you can use like the union version or the brackets, parentheses version of writing domain, or I can also say in words, the domain of this is all real numbers except, what are the two numbers I just found made my denominator equal 0? 2 and -2. So I'm going to say except positive and -2. Okay, so it's negative infinity to positive infinity until I hit -2 and until I hit +2. To me, sometimes I would rather write it out than to write like negative infinity to -2 and then -2 to 2 and then 2 to positive infinity. To me, that's a lot of writing. So I like to do sometimes just writing it out instead. What is another one? Okay, one other one. We're going to identify the domain of f of x equals y plus 2 with the square root of y minus 10. So this was not going to be quite as obvious at first, okay? So you start thinking, okay, well, it could be my denominator, maybe something's going to make my denominator equal 0. Okay, well, I'm also in a square root. So the root is what's bothering me the most. The root is what's telling me that's what's going to make something go wrong. If you remember anything about Algebra 2, I want you to think about, is this a real number? The square root of -6, is that a real number? Hopefully you're like, ding, ding, ding. If you had me, like, no, Ms. Norman said a million times, you cannot take the square root of anything negative, right? That's going to create something with an imaginary number, or I. So when I'm looking at this one, something that's going to make this not a real number, a real function, is a negative in my root. So what numbers are going to create a negative in my root? Let's start working some numbers out. If I take 1 minus 10, is that going to be negative? 1 minus 10 is -9, so yes. If I take 8 minus 10, is that going to give me a negative? Yep, that's -2. So very clearly, I hope you'll see that even if I have 10 minus 10, that's still 0, and I don't want the square root of 0. So what if I had 10.00001 minus 10? That is 0.0001, right? So I'm over that 0 hump. So basically, if I have anything where y is greater than 10, for my denominator, that works, right? I just have to get over that hump of 10. It can be 10.00000000001 for all I care, right? It just has to be greater than 10. So I'm not going to say the equal sign. It's not greater than or equal to. It just has to be greater than, because I can't be equal to 10. Does that work for my numerator? If y was 11, right, that's greater than 10. Does that work? 11 plus 2 is 13. So yeah, that works, right? For my denominator and my numerator, that works.
So for this one, it would be all real numbers when, and I'm not going to say except, because this is all, it's only true when y is greater than 10. So all real numbers when y is greater than 10 is going to be your domain for that one. Okay, that's all I have for this video. So you'll be getting the homework to this. Let me know if you have any questions. Thank you.